Welcome to EDU World Space.
So in this question, we have to find the longest wavelength if of a photon that could produce a proton-antiproton pair, each with a mass of 1.67 times 10 to the power minus 27 kg. So the photon with the longest wavelength has the minimum energy in order to create the masses with no additional kinetic energy. So what I'm trying to say is, so let's use equation 27 6 here, which says that energy is equal to h times the Planck constant times the frequency, and frequency is equal to c over lambda, as we know. So energy is equal to hc over lambda, which means that lambda is equal to hc over E. Now, if we want the maximum or the longest wavelength, the energy should be minimum because lambda and E are inversely proportional and hc is a constant. So, yeah. And the minimum energy, I'm just going to write it over here. Now, the minimum energy a particle can have is the rest mass energy, or the energy when the particle is not moving, which is equal to just mass of the particles times c square. Now, since here the photon is producing a proton-antiproton pair, so the total minimum energy we need should be equal to 2 times this mass, because there are two particles or a pair, each with the same mass m. So we are going to use this value over here. So lambda maximum is equal to hc over 2mc square. This gives lambda max is equal to h over 2mc. So h is the Planck constant, which is 6.63 times 10 to the power minus 34 joules times second. M we already have here, and c is the speed of light. So using all those value into this equation, we get lambda max is equal to 6.62 times 10 to the power minus 16 meter.